Okay, Physics 30s, page 94 of the workbook. Let's take a look at some problems on Young's double slit experiment. Okay, so let's remember the basic equations. You have the following. You have lambda equals d sine theta over n, and you have lambda equals dx over nl. Only when the angle of deviation from the bright spots, right, is less than 10 degrees. Okay, that's when it applies. All right, now let's take a look at question number 1. Monochromatic EMR is shown through a diffraction grating, distance between the slits, 2.5 micrometers. If the angle to the second order maximum is 11 degrees, then determine the EMR frequency. Okay, so what I can do here is I can use the equation for diffraction. Since I see it's 11 degrees, I'm not going to use this equation here. And so I'm going to put in what I have. Well, I have the following: 2.5 micrometers. Multiply that by sine of 11 degrees and divide that by n, which is a second order maximum, so n would be 2. And the calculation. All right, I get this. 2.385112 e negative 7. Now that would be the wavelength. It's asking for the frequency. So using the universal wave equation, frequency is the speed over the wavelength. So 3e8 divided by 2.385112 e negative 7. I get the following: 1.26 e15. Okay, question number 2. 620 nanometer EMR is shown through a diffraction grating, distance between the slits 9.9 micrometers. If the distance from the grating, okay, 80 centimeters, I determine the distance between maxima. So distance between maxima would correspond to the x variable in the equation. Okay? And so what I'll do is I'll solve the equation for x. And so x would be equal to lambda nl over d. So lambda 620 e negative 9. Between maxima would be an n value of 1. And then we have 80 centimeters, 0.8 meters. And then the diffraction grating spacing, 9.9 e negative 6. Okay. 0.0501, and so we're looking at two significant digits here and here, and so the x value would be about 5 centimeters. Notice it says, right, assume the theta is less than 10 degrees, so we can obviously apply that second equation. The third one, 470 nanometer EMR is shown through diffraction grating that is 36 centimeters from the screen, and the distance between the maxima is 11 centimeters. Determine the distance between the slits. So that would be the lowercase d. So solving for d, notice the idea of no angle being given. So, and the distance. So what we want to do is we want to right away just use our second equation here. Okay. Then again, we can double check the angle. Distance between the maxima is 11 and the diffraction grating, that L value is 36. And so we could figure out the angle. So let's do that first, maybe just to double check. So tangent of the angle is going to be 11 over 36. And so the angle would be inverse tangent 11 over 36. And so the angle is actually 16.99 degrees. And so what we'll do is we'll realize that this equation probably shouldn't apply because the angle is larger than 10 degrees. So I'll use this equation. Okay. Now what I'm going to do is I want to figure out the distance between the slits. Well, I need to first of all figure out what information I can find, which would be the d value. So the d value would be lambda times n over sine of the angle. So lambda 470 times n over sine of 16.9908. (1.6084) e negative 6. And so I want two significant digits, so it would be about 1.6 e negative 6 meters, or 1.6 micrometers. Okay,